astronomers have discovered the largest cosmic explosion ever, and it is many times brighter than any stellar explosion or supernova we have ever known. Its duration of brightness lasted up to 3 years, while most supernovae only shine for a few months. According to The Guardian, this fireball is 100 times larger than the solar system, 2 million times brighter than the sun, and in just the past 3 years, it has released energy equivalent to 100 suns releasing energy over their entire 10 billion. The explosion, named AT2021 is still being detected by telescopes. It occurred nearly 8 billion light-years from Earth, when the universe was only about 6 billion years old. Its brightness is 3 times stronger compared to tidal disruption events, when stars fall into supermassive black holes. But what triggered such a massive and long-lasting cosmic explosion? Astronomers believe that a supermassive black hole swallowed a huge cloud of gas or dust, likely thousands of times larger than our Sun. It is possible that the cloud was pulled out of its orbit and fell into the black hole, researchers say. The AT2021 LVCFX event has surpassed the brightest cosmic explosion ever recorded, the gamma ray burst GRB221009, and reported in 2022. Actually, the gamma ray burst GRB221009A was brighter, but it only lasted for a short time compared to AT2021 LVCFX, so the total energy it released was less. Astronomers first detected the explosion in November 2020 by the Ricky Chanson facility at Palomar Observatory in California, and later by the Atlas system in Hawaii a few months later. The lead author of the study, Dr. Philip Wiseman, a researcher at the University of Southampton in the UK, said in a statement, "We accidentally discovered this when our search algorithm flagged it while looking for a type of supernova. Most supernovae and tidal disruption events only last for a few months before fading away. Having an explosion that remained bright for over 2 years from the start was already very unusual." Follow-up observations were conducted by the Neil Gerald Swift Observatory, the Hubble Space Telescope, and the New Technology Telescope in Chile, and the Gran Telescopio Canarias in La Palma, Spain. Researchers were able to determine the distance between Earth and the explosion by analyzing the different wavelengths of light used to observe it. Co-author of the study, Sika Siene, a professor at the University of Southampton, said in a statement, "Once you know the distance to the object and its brightness to us, you can calculate the brightness of the object at the source. The Atlas system observed the explosion several nights a week over the past 2.5 years, and the research team determined that this event is nearly 100 times brighter than all 100 billion stars in the Milky Way combined. The only celestial objects comparable in brightness to AT2021 LVQX are quasars, or supermassive black holes continuously sucking in surrounding gas and dust at high speed." The research team proposed initial hypotheses while studying the brightness of the explosion. Now, they want to collect more data across different wavelengths to learn about the details of the event, including its temperature. Co-author of the study, Dr. Matt Meeker, an associate professor at Queen's University Belfast in Northern Ireland, said, "Initially, we thought this bright event might be the result of a black hole swallowing a passing star. But our models show that the black hole would have to swallow a mass 15 times that of the Sun to maintain such brightness for so long. Encountering such a massive star is very rare, so we think it is more likely a large gas cloud. Many massive black holes are surrounded by gas and dust, and we are still trying to understand why. This particular black hole started absorbing so intensely and suddenly." The Hubble telescope found a mysterious star that died up to 5 times. The Hubble Space Telescope captured images of the unfortunate star that died up to 5 times, spanning from 1990 to 2016 as observed from Earth. As we know, the universe changes very rapidly and is constantly expanding every day. This leads us to encounter puzzling cases, such as observing the death of the same star multiple times. A notable unfortunate star is a supernova named Repton. In 2014, observers first detected the image of the supernova through the Hubble Space Telescope. However, what surprised them was that the same star emitted bright light at 5 different times, including once in the late 1990s, twice in late 2014, once in late 2015, and once in early 2016. Interestingly, each time the star shone brightly, it exploded into dust and could never recover. In other words, we have observed the death of the same unfortunate star 5 times. Why is there such an absurdity? According to the explanation, light from the supernova is emitted in all directions. But as the light travels through space, it is distorted by the immense gravitational field of a massive galaxy cluster. This causes the light of the supernova to reach Earth via multiple different paths. In other words, each appearance of the supernova reached us through a different path in the universe. Imagine 5 trains leaving the same station but taking different routes. Then, due to a strange arrangement of the universe, they arrive at the same destination but at different locations and times. According to scientists, by observing the appearance of supernovae on Earth, we can measure the time it takes for them to travel. From that, the explosive conductivity of the universe during the luminous secretion movement can be calculated, called the gravity. Additionally, there are other methods to measure the gravitational constant, such as based on a cosmic microwave background, including residual light or radiation transmitted through the universe shortly after the Big Bang. NASA has captured an unprecedented blue celestial object, formed 13.4 billion years. The spectacular image from the James Webb Space Telescope, primarily developed and operated by NASA, has revealed a group of celestial objects hidden in the early universe, superstars never before seen in any previous era. This group of celestial objects formed just a few hundred million years after the birth, and the image scientists are observing is also a time-traveling image from that primordial world. Because light also takes the corresponding time to travel the 13.4 billion light-years to the telescope orbiting Earth. They are superstars beyond imagination, larger and hotter than any blue stars, the hottest type of star humanity has ever known. If compared to the Sun, a yellow G-class star, which is a type with a temperature slightly below ours, these celestial objects have masses 5,000 to 10,000 times greater. They also have core temperatures reaching up to 75 million degrees Celsius, much higher than the 15 million degrees Celsius in the Sun's core. However, despite their astonishing size and temperature, these celestial objects are very difficult to observe, as they are a type of star with a very short lifespan. The team of scientists led by astronomy professor Corinne Chardonnat from the University of Geneva, Switzerland, has found signs of this group of celestial objects in data from James Webb. These celestial objects assemble into globular clusters, each containing up to 1 million stars, formed together at as early as 440 million years after the Big Bang that gave birth to the universe. Globular clusters are a structure observed many times before, but globular clusters this ancient, and the type of giant superstars they possess, have never been recorded. To locate these celestial objects, the research team used infrared data from James Webb, focusing on analyzing light from one of the most distant galaxies, GNZ11, located about 13.3 billion light-years. The image obtained is from when this galaxy was only a few tens of millions of years old, making it an ideal place to search for young star clusters, collecting light from the ancient galaxy, separating and filtering it. Scientists have detected a special scientific signature of the aforementioned group. Thank you for watching the video.